Hello everyone, today I will introduce the UHV-8003 partial discharge detector, independently developed by Wuhan UHV. This product can be widely used for partial discharge detection of power systems, including high-voltage switchgear, ring main unit, CT, and PT, transformers including dry-type transformers, GIS, overhead lines, cables and other equipment insulation status detection. This product has the following features: configure different sensors, realize partial discharge detection of almost all high-voltage electrical equipment, provide time-domain waveform PRPD, PRPS and other discharge spectra, realize analysis of different discharge types, built-in ultrasonic sensor and TEV sensor, can be connected to external transformers, GIS, overhead lines, cables and other special sensors, adopt non-invasive detection method, no need to shut down the power during the test, no need to configure high-voltage source, more convenient than traditional pulse partial discharge detector. Test bandwidth range is 30 kHz to 2 GHz, applicable to the detection principle of various frequency bands. This product is mainly used in power distribution enterprises, railway system, petrochemical power supply system, aerospace detection system, and automated detection field. Next, the main components of the instrument are introduced: instrument host, UHF ultra-high frequency sensor, AE contact plug sensor, HFCT high-frequency current sensor, external flexible non-contact sensor, as well as headphones, signal lines, chargers, coupling agents, etc. After the introduction of the instrument part, next, the operation video of the instrument is explained. The test product uses the switch cabinet partial discharge teaching system tooling. Now let's start the actual operation of the instrument. After the instrument is turned on, it will enter the TEV sensor test interface by default. First, record the background value of the environment when doing the TEV test. At this time, turn on the power generation switch of the tooling. When doing the TEV test of the switch cabinet, just press the TEV sensor at the front of the instrument against the cabinet of the switch cabinet. Click Save after the measured value is stable. You can choose the save location when saving. Select the switch cabinet as the test equipment. Then select, and click OK. When the switch cabinet needs to be tested at multiple points at the same time, just take a test point at the bottom. After the test is stable, the same storage steps, just store the data. The TEV sensor test is completed. Next, the test method of the non-contact ultrasonic sensor is introduced. First, use the built-in non-contact ultrasonic sensor. Just click the switch in the lower left corner to switch to the ultrasonic sensor state. When testing the non-contact ultrasonic sensor of the switch cabinet, just move the non-contact ultrasonic sensor on the top of the instrument, slowly along the gap of the switch cabinet. If an obvious partial discharge signal is found during this process, you can stop and save the data and spectrum after the test is stable. The saving method is the same as the TEV saving method. The instrument's built-in non-contact ultrasonic test method is introduced. After introducing the instrument's built-in non-contact ultrasonic sensor test, the instrument's external non-contact ultrasonic sensor is introduced. Insert the sensor signal line into the bottom socket of the instrument. At this time, you can see that the upper left corner of the interface automatically switches to AA1, which means that the instrument has switched to the external non-contact ultrasonic sensor test channel. The external non-contact ultrasonic sensor is also called a flexible sensor, which is used when the switch cabinet is close to the wall or other objects. This sensor can be used when the instrument's built-in non-contact ultrasonic sensor cannot be used for testing. This sensor can be bent freely and has high sensitivity. The test method is the same as the instrument's built-in sensor, non-contact sensor. Next, turn on the discharge switch. Similarly, we move slowly in the gap of the switch cabinet. And in the process of moving, the same as the built-in non-contact ultrasonic sensor, the cabinet cannot be bumped during the movement. When moving, stop moving when an obvious abnormal discharge signal is found. Click Save after the test is stable. Store the results inside the instrument. The test of external non-contact ultrasonic sensor is introduced. Next, the test method of the contact ultrasonic sensor of the instrument is introduced. First, insert the test line of the sensor into the interface at the bottom of the instrument. You can see that the upper left corner of the interface is switched to AE. It means that the instrument has switched to the test channel of the external contact ultrasonic sensor. Before testing the contact ultrasonic sensor, the coupling agent should be evenly applied to the contact surface of the sensor. After applying the coupling agent, turn on the discharge switch. The sensor can be directly adsorbed on the surface of the test body. You can see that the instrument has measured the discharge signal. After the test is stable, click Save here. The saving method is the same as before. The test method of the external contact ultrasonic sensor of the instrument is introduced. The test method of the HFCT high-frequency current sensor is introduced below. First, connect the signal line of the sensor of the instrument to the port at the bottom of the instrument. At this time, you can see that the upper left corner of the instrument interface has switched to HFCT. It means that the instrument host has switched to the HFCT high-frequency current test channel. Then connect the high-frequency current sensor of the instrument to the ground wire of the cable. Turn on the discharge switch. At this time, you can see that the instrument has measured an obvious discharge signal. After the instrument's measured value stabilizes, click the Save button. The test results can be saved in the host. The HFCT high-frequency current test method is introduced. The following introduces the test method of UHF ultra-high frequency sensor. UHF ultra-high frequency sensor is generally used for partial discharge detection of GIS, and the test point is usually located at the flange of GIS. Here, the observation window of the tooling is taken as an example of the test point. First, insert the test line of the UHF high-frequency current sensor into the bottom port of the instrument, and you can see that the upper left corner of the instrument interface has been switched to UHF. Indicates that the instrument host has switched to the test channel of the UHF ultra-high frequency sensor. Press the sensor against the observation window of the cabinet. Turn on the discharge switch. At this time, you can see that the instrument has detected an obvious partial discharge signal. After the measured value stabilizes, click Save. Save the saved result in the instrument host. The test method of UHF ultra-high frequency sensor is introduced.